control. Natural pest and disease. Okay? 6. Yes, Tadiwa. Reproduction. Give him a hand clap. Don't be surprised if this you don't find it anywhere in the books, because this is ours. That is for APN.
But if you plan on implementing, and you haven't done that, I guarantee you're not going to go anywhere.
True. You'll be missing a key aspect. 7. Multiplication is the reproduction. Yes. Okay.
The optimization of use of land.
Optimization of land. Eh?
Yes.
I think that can come in.
These all fall within that. That's correct.
It is correct. It is an explanation, because when you are maximizing your piece of land, that means you find yourself densifying, you find yourself diversifying, and then stratifying. Okay? Yes, Damascus? Soil cover. Guys, soil cover. Okay? And in soil cover, you saw that you can use the green cover and dry cover, but the soil, we should always try to make sure it is covered. Eh? Pardon? It is a principle, because you have to ensure that your systems are permanently covered to protect your microorganism life and protect your soils too. The bare the soil, you know what happens. In case of rains, it is. In case of the too much sunshine, okay? 8.
I think if you have to cover after reproduction, you should have
The economics. Economics, yeah. Should we include that as a principle? But
it's again the result. Huh?
It becomes a result.
When you follow these principles. When you don't follow these principles, it's not economic.
That's what I would think.
Remark.
Yeah, very good.
We are working on a consequence out of it.
That is very true.
Very
So
good question.
at the end of it all, you should always ask yourself, is what I'm doing economical? But if you don't follow this, you won't have your answer to that. Yes. Feeding the soil. In feeding the soil. Of course it is key, but where does that come in? This one basically helps you feed the soil. Densification helps you feed the soil. Perennial photosynthesis helps you feed the soil. Are you saying? Soil cover helps you feed the soil. This one helps you feed the soil. Eh? So it is also a consequence or a result. Yes? Let's give him a hand clap, guys. Thank you so much. By the way, he's my fellow engineer. We are engineers. So 8, proper and timely. I'm not a minister. Proper and timely system maintenance, all management. Eh? All right, 9. You think they are finished? Yes, Really?
You kept talking about taxation.
Oh, guys, give him a huge hand. Give her, sorry, my chiga. Plant succession. You see, Ogbe doesn't want to be called a Mchiga, but she has all the principles of Machiga because we are very clever. Please admit it. 10. Yes. Adaptability. That is something you should keep in mind when you are designing. Yes. Okay. Another one. You're still there. At least one more to go. Guys. Crack those heads. Crack those brains.
What is part of an intelligent system?
Yeah.
No, that's NI.
Eh? Guys, climate? No, those are just, you need them when you're designing to mind about where you are. But there is one aspect, guys. Where do cows fall? Where do animals fall? Nutrient cycling is just, how do you bring that up? Integrated animal husbandry.
It's IA and AIR. What's the difference?
It's AI, yes.
So you see, guys, sometimes you will be reading out there. What we are teaching or what we are letting you know is, these are not the, you find, such that you find them everywhere, okay? Most of these things, we come up with them from experiences. The first time we trained, we had like only 6, but now we are up to 10. Because from experience, we see that there are key issues you have to always add on. And when you read, you might find that people don't mention most of these things. But from your own perspective, don't you think that they are really important? Okay? So even if you forget the rest, mind this. Remember them. Because these will be key in your designing, key in your maintenance, and really key in ensuring that you have successful agroforestry systems. Thank you so much. Allow me hand over the floor to Papa Frutig and Fred, who are going to take us through. Who are going to take us through the next
You
phase.
heard what Lucky said. They've gone from 6 to 10. Since I've known these guys, they confuse me because I'm not sure what they're looking for. I understand. So don't feel bad if you didn't quite get it, because they have me confused for a bit too.
Okay, guys, now let's dive into a subject that may look like troubled waters for you, because it's not so easy to understand at the beginning. You'll see we have some fairly complex aspects to look into, but there's a lot of logics behind it. There's a lot of logics in how nature works. It's all part of how nature works. The key thing is our agroforestry systems can only function properly when we at least roughly understand how nature works. And all the observations we are actually making, we try also to learn from what has been analyzed by scientists. But we also learn the limitations of certain analyses because we see different results in nature. So let us dive into these subjects where nutrient cycling, as I started already in the intro, it's about why is it happening as you have seen it yesterday in the field. There are reasons behind that. And you see, you guys all look quite healthy. So you probably get reasonable food. When you don't get reasonable food, probably you would sleep here because you don't have any energy. Some people would be in the hospital because they fell sick. So it's basically about, you remember the two questions I was always asking at the beginning: what is feeding your plant and what is protecting your plant? Protecting is pest control and feeding is nutrient cycling. Remember, nutrient cycling is part of the three main cycles: water, carbon, nutrient cycles. So it is important that we start understanding the interconnectivity of all these things. We are creating individual subjects here, but everything is interconnected, and you see it when you go out to the field. I think we don't need to work on the table of content. It's when we ask the question why, we always have to see what is the root cause of our problems in agriculture. And that is deficit agriculture mainly. And we see that the weather extremes that are happening now due to climate change, they are acting like a catalyzer of the problems we already have that are caused by us. It's a consequence out of that, but we have seen it here within 1 week. The heavy rainfall we have had, when you went down, when you were looking in our fields, there were no damages in our field. There was no runoff. There was no loss of soil in our fields. But when you were looking, when you were walking around the road, you could see a lot of runoff, a lot of soil that has been washed away. So we need to think about what we are actually dealing with, and the monocultural agriculture, as we have looked at it already, is one of the most, the strongest impacts actually that is causing our problems. So it's all about these print, and you see, we come to the lack of this one here. The reasons, what we are setting up here, it's all explained. These principles, they are not followed. So they have consequences. Because what we try to list down with the principles of agroforestry is basically how nature works. We are mimicking a forest. So we try to mimic how nature works. And here we see we have actually intervened into nature in a way that nature doesn't work anymore, doesn't function anymore. But be assured, nature can be without us. But we can't be without nature. So that's an important thing. So Uganda is probably one of the hotspots when it comes to degradation of landscapes. You only have something like 10% forest left, which is a real catastrophe along the equator. Because you are sitting in one of the most important climate leverage effects where you can, the global climate depends highly on what you are doing here. So when you are destroying your own nature, it affects me as well, even when I'm not living here. So it is a big thing. One of the big reasons that is also behind our problems is that we start thinking about good and bad. You see, in the past, we always have tried to identify the good bacteria and the bad bacteria. We wanted to get rid of the bad bacteria. What does that mean? You see, it's the subject of medicine I have mentioned already a second or a third time. When you take too much medicine, it becomes a poison. When you think you can only take good bacteria, you only eat things that has good bacteria, your body immediately will create the next pest. Because it's not balanced. So it's all about balancing, and you see, today we try to disinfect our landscape. That's the monocultural aspect. Now we are using antibiotics like glyphosate that is actually sprayed in the landscape. But what we are doing in the agroforestry system is balancing everything. Do you balance temperature on the left-hand side? No. There is no cooling down. There is no cooling down happening. On the right-hand side, there is a permanent cooling down happening. Next, please. And of course, the bitter truth, using all these pesticides, whether they are herbicides, fungicides, or insecticides, the side effect is always killing microbes. It's always killing. When you take antibiotics every day, you will not survive further attacks of bacteria or fungi anymore, because your body, the whole body has built up resistance against it. You will not survive. You will die. But we try to do the same thing with the landscape. What we know that it doesn't fix. So in most of our soils, I'm always really, I enjoy when people say we have bad soils. You cannot do that here. There's no bad soil. There's only badly treated soil. Because what is the most surprising thing, even in the sand in the desert, there are plenty of nutrients available, but they are not available to the plants. So we have to make them plant available. So these interactions between the soil life, microbes are the most important part of the soil life. And remember, they are the same here. They are the same here. It's very similar. So think about that when you think about food, because today we are talking about food for plants. How does that work? So especially also for nitrogen is always an interesting subject, because nitrogen is available in huge amounts in the air. We just need to understand how the nitrogen from the air can be transformed in a form that the plants can pick it up, and the microbes play a key role for that. So we always think we have to add, but that comes from the deficit analysis. It doesn't work like that. Nature doesn't work like that. So it is important that we start thinking about the big picture. How are all these components working together? And when we are talking about the carbon dioxide subject, carbon sequestration can only happen properly with the microbial activity. It won't happen without the microbial activity. So you see, we have so many things. Phosphorus, there's plenty of phosphorus in most of the areas. We have a huge stock that is never available for the plants, but we still are adding phosphorus. The microbes make it available, and we need the diversity in the microbes, that we can get all these different kinds of nutrients or nutrients that are existing in the soil. So we need to look very carefully at these aspects. And you see, when it comes to carbon, if you have no carbon in the soil, the microbes have a problem. It's part of the whole cycling. If we don't have carbon in the soil, we cannot store the water. It's all interdependent. But the whole carbon dioxide discussions, from my point of view, they go a little bit in the wrong direction. But we know that it is important. But carbon dioxide, when we are looking at today's situation, everybody tries to reduce the emission of carbon dioxide. They are even discussing about whether the cows that are farting, whether they are contributing to methane and carbon dioxide emissions. What a stupid thing. You see, when we think like this, then you also have to stop talking, because you are emitting carbon dioxide. So it's a stupid thing. It's the wrong thing. But it is important that we know carbon sequestration only happens when we have greenery greenery, when you have photosynthesis. Without the photosynthesis, it's not going to happen. Next, please. Again, we have seen that interdependence. Always think about that the photosynthesis is a driver of the cycle. It's even a driver of the water cycle, because water storage only happens properly when you have photosynthesis, when you have greenery, when you have living plants. The living plants, they are feeding the microbes. So all these interdependencies, they are really essential. So a lot of analyses tend to, let's look at the humidity only. Then let's look at the soil organic matter only. Let's look at the nutrient only. All these reductionist considerations, only looking at a piece of the cake but not at the full cake, they lead to wrong understandings. They are actually misleading the farmer in a direction where he doesn't know why he's doing what he's doing. Because the farmers, they have been disconnected from the soil. That is one of the big problems we have today. Next, please. So, regenerative agroforestry, as we see with all these principles, we are linking and we are making these natural cycles happening. We assist nature that these cycles can function in a proper thing, and biodiversity is always the kickstart. It's always the first thing. When you think you can plant 10 trees of the same variety and you are done, it doesn't happen. It doesn't happen. The more different plants you have, and you see all the stratification we have discussed, the different root systems means also different microbes, they get different access to nutrients. Now, when it comes to the soil organic matter, the carbon plays a key role. And how do we get carbon into the soil? There are two main processes. One is just the decomposing process. When the leaflet falls down, it's decomposing. Who is decomposing? Microbes. Are there some other guys? Maybe, Maybe. Think about earthworms. There are many. There are a lot of actually companions working together in this process of decomposition. And that's important to know. In the decomposing process, the majority of the carbon goes up to the air, and a slower part goes down to the soil. Now there is another pathway of carbon, and it's called a liquid pathway. It works when the plant is producing carbohydrates. It puts it down to the roots. It shares it with the microbes, because this is the food of the microbes. Sugar. It's sugar that is being produced. That's carbon. That is carbon. We have to keep that in mind. This process, when you have a living plant, is 5 times faster than the decomposing process and much more efficient than the decomposing process, because only 30 to 40% of the carbon oxidizes again, goes back to the air again. So we have a much bigger storage of carbon happening when we have green plants. The permanent photosynthesis. That's a key thing we have to look at. Next, please. Now, you have seen in several parts of the campus, land has been transformed. Land has been transformed from different structures. When we are looking at the initial situations where people have had monocultural structures, the typical thing is you have very low soil chemistry that is functioning properly. That means low fertility. In the initial phase, you do plowing, you have all these aspects that are disturbing the soil. And the most important thing is here, you don't have the permanent plants. You don't have the permanent greenery. In the monocultural system, the permanent greenery is mainly missing. So there is no self-regulation of the system. This is the deficit system where you add always chemical. But does adding chemicals helping to support the life? No, it doesn't. It doesn't really soil. When we go to the tillage, we are talking about the physical aspects. What happens when we are tilling? What happens when we are tilling? Yes? What happens when you expose the soil? When you turn it around, you put part of the soil up. What happens with this? What about the life, the soil life? The soil life is affected heavily because you destroy a lot of the soil life. And that is one of the big impacts actually that is coming. And now when we are coming to the next aspects, when we start looking at the soil fertility as a main subject, we start looking at the biology. We want to promote the biology. So we have a permanent greenery. We are integrating into these structures. You see, from the deficit system is normally a system without trees. So there is no permanent photosynthesis able to happen. So the more you are adding the complexity of the system, the biodiversity, the more you start working on the chemistry, on the physical properties, and on the biological properties. The more complex, the more you are actually promoting your soil biology and chemistry together. You are storing and you are cycling the nutrients. What does that mean when we become more complex? Are we the manager of this system? Nature starts managing the system itself. It's not the human being anymore that is managing the system. It is basically nature that starts to act on its own. And it makes it work without our influence. And sometimes you will see surprises, because nature does not always react in the same way as we are thinking. But it is a very important part that we start learning. We have a lot of degraded soils. So we always go through such kind of processes. Agroforestry helps you to jump fast into a complex system. You can also do it slow, as we have mentioned, when you first only try to work with the fodder systems, because the farmers, they have cows. You are making an intermediate step before you go to the full complexity of the next system. Next, please. Now we are coming to the subject that is basically Fred's center activities. We are looking at the soil life, the biology of the soil, which actually a key thing we need to have in mind. All this, when we are looking here you see it's mentioned trophic levels. What does trophic levels mean? All this is a food chain. A food chain. It starts with those who are decomposing the plant materials. We have with the bacteria, the nematodes, the arthropods, nematodes, protozoa, all these. Each one is eating on the other one. So they are interdependent. What happens when we are taking out some of the bacteria and some of the fungi?
Cut off the chain.
You cut the food chain. Can you give me an example what that means in your own nutrition? Yes?
If I take many medicine, moms,
Your microbiology is going to suffer. So it has an impact that is actually cutting out a part of your digestion system.
so my stomach will
Yes, so
be unable to.
there will be a reaction in your body. So that's, and you see, we have a huge discussion also with the composting. A lot of people are I think we also have a person from the biodynamic movement, right? You work a lot with composting, right? What is happening in this process when you do composting?
When we do composting, there is production of living organisms, whereby the organisms start feeding on themselves to make our compost back to soils again.
So what is needed to do composting?
Plant materials and cow
From where are you going to take the plant material?
plant remains from our gardens
Okay. Yes.
and cow dung or,
Yes.
or manure. Those are the only ingredients we add in our compost.
So you take some organic material out of your system, you separate it, you add the cow dung, and you have a decomposing process outside of the field. And then you put back the compost because this has a higher quality. I have a question. What happens to your food chain here? You see, you have cut out a part of the digestion system. You have put it outside. And now you bring another product back. What do you think is happening in the food chain?
Is the adaptation.
We have to adapt again.
But maybe something has disappeared, Maybe.
What if you took your teeth out and all your food now be, because you no longer have your teeth, and that happens, it's ground up and now you eat it. It changes the consistency of the food. It changes the way the system works. In other words, it's not saying that what biodynamic, because I have family and members and friends that work with biodynamic systems, it's not saying a right or wrong, it's just saying the way nature works isn't to pull something out, but it's to reinforce it. In other words, it needs to remain within, and that's something within any of these systems we have to realize is we need to keep, we need to understand the holism and why things are working so we can keep them working within the system versus taking them out and thinking we can do better. Because that's what we do when we, in some of our fields of medicine, we think we can do better when we're approaching it, with good intent, but probably from the wrong point of view.
And another reason as to why we do composting is because when you leave cow dung or cow manure to be open, of course, it emits methane. So we also decrease on the emission of bad gases in our atmosphere.
I'm a bit doubtful whether this is a correct view. Because you see, when we are not taking this decomposing process, but we are putting the cow dung in the system instead of taking the material out. That means integrated animal husbandry, actually. The problem is, you see, I'm not against composting. I know it works. But are we not interrupting here a part of the food chain in the soil because we are taking it out? You see, it's a bit like when we are eating something, we are also creating, our stomach is also creating a fermenting process as it's part of the digestion. Now, some of our food, what we are eating, we are fermenting. What is happening when we are getting fermented food? It is a little bit like a pre-digested or a eased up digestion, because one process has already started in what we eat, what normally happens in the body. And that's a bit what, you see, I know you have been to second, right? So, do you understand how much the costs are?
Of course, they are high.
So, you see, we are also, again, talking about economy. When you are removing plant material from the field and you're bringing it back later on, that is something you need to look at. Maybe Fred can still start explaining a few more details in the slides. Yeah.
Because there's something here, I don't like to concentrate on slides, but let's just not worry about these slides.
Yeah, it's not the title there.
Don't get to talk about these things when we're not here talking in the class. But you can jump in anytime, but anyway. Yes.
Sorry, I thought that you were speaking many things. I thought we would have, talking about that, I just remembered, yesterday we saw the cabbage.
You saw the what?
The
Cabbage.
Okay, cabbage. I'm sorry, I wasn't with you yesterday. I've been really tired in the afternoon.
Okay.
Interesting concept was 1 square meter had, I don't know, counting, but there were like 50 plants,
Yeah.
different species, and most of us who plant cabbage had convinced me that cabbage can go to that level without any infection. And it was very obvious, observed, I didn't see any diet or any.
Yeah.
Once you speak about this, it makes sense.
Yeah, okay.
That the whole cabbage is full of the natural good microorganisms, but there's no space
Yeah.
for the bad fungus.
Yeah, we increase the chance of the plants to be healthy. You know, it's not guaranteed because they can still be overpowered. And, but when that happens, there are things that they will show you that can be done, some applications that can be made, but they're all using the microbes. This is a really interesting thing too, because briefly, I'm going to just wind down. I know I'm talking fast. There's a lot of material. I wish, you know, if I had a whole day, we could deal with this, but, or a whole week even, we could do a class in it. But an interesting thing about the microbes in the soil, and we'll just go to the bacteria and the fungi, is the bacteria we have in, there was a chart up there that showed, it said phosphate PSB, phosphate solubilizing bacteria. Well, we also have phosphate solubilizing fungi that and they just go out there, secrete these enzymes that allow phosphate to occur. But the enzymes, each of these create the nitrogen that comes out of the processes of the fungus are in the form of ammonia. And ammonia ions tend to create a more acidic soil. The nitrogen that comes out of the processes involved in the bacteria create, your nitrate. And your nitrate and your ammonia are the two forms of nitrogen that plants take in. So as we increase the bacterial portion of the soil, it becomes more alkaline. As we increase the fungal, it becomes more acid. So as you go into a forest, there'll be more acid. Go ahead. And then you'll see certain plants also tend to fall into these areas of, they like alkaline or acid soils. And anyway.
The interesting thing is, and for the farmer important thing actually is, you see the desert plants, they are more on the bacterial sides, and the trees are more on the on the fungal side. So what is missing? You see all our monoculture systems with seasonal plants, they are basically working on the upper side. So they are basically working on the bacterial side. So when you analyze the soils in the seasonal crop systems, normally fungi are lacking. You don't have a balance. And when you see here a neutral pH, it means all the plants can pick up nutrients. And this, more or less, but this is regulated also with humidity. You see, the humidity plays a key role. The drier it goes, the more we have the salinity problems. The more wet it becomes, we have the more acidic structures we are getting. The interesting thing, what for me, the mind-blowing things I learned out of this sketch was actually, you see, when we combine the trees and the desert plants and the grasses all together, we automatically start neutralizing the pH situation.
So
When we have high biodiversity in it.
let's take it from here for just a second. And that is, yesterday I was having a very good conversation after lunch with one of the young ladies here. Mona, Elisa and I were talking, and she was talking about how harsh it is where she's from, Zimbabwe. And she was saying about the sandy soils. Well, we have a lot of sandy soils in Malawi too. The interesting thing is, we used to think about soil chemistry and soil structure, and that was how we measured things, and that's how we responded, by available nutrients, by the structure and what we needed to do. But what we know now from what Roland just said is we look at the soil biology, it will help us determine where the soil pH is. And it can change over time. And what happens with the carbon that's created down there in the mycelium when the soil is healthy is it actually creates something called glomalin, which is from a certain type of a protein. And when the hypha, the little long, thin threads in it die, they create something in there that binds the soil and creates a soil structure. And suddenly we got humus forming in there, which these are long chains of carbon, and they lock up in there and they hold moisture and they sequester carbon. And it takes about 100 years for these to break down. So they're sequestering carbon. And the interesting thing is, if you think you have to spend money on soil tests, you're just wasting your money as far as I'm concerned. If you want to test something, test the fungal bacterial ratios. And we have a kit that we do that with, but I didn't bring it because we found in some of the trainings people then they want to just pay attention to this kit, where that isn't what we're trying to get them to look at. We're trying to get them to understand that it's a fungus bacteria ratio that we need out there, and that'll help us determine our pH. It'll help us with our soil structure, and we know that in a sand, as that comes in and gets better and better in a sandy soil, guess what? More organic matter is put into that sand begins to change. I can take you into an area where there's sand, and once this system's been in place for even a year, you're now picking up soil that's holding moisture and stuff.
Now, a key thing, you see, this is abstract, A key thing is now, what does it mean in the practice? I give you an example from India, where we started in the desert, sandy soils, no organic matter, and we combined the grasses together with the trees. We had a pH of 8.5 at the starting point. After 2 years, we are at 7.5. So salinity reduced. We are irrigating with saline water. And we have salinity in the soil. But despite that situation, with the densification of the grasses, especially the grasses are the biggest producer of biomass, and they produce a lot in a very short time. They are the drivers in this system. And that means we can convert degraded soils that are on the desert side or on the wetland side. We can change them within a very short time. Very short time. It only depends on the biomass and the diversity you are adding to it.
So to me, there is one question. Everything that I've said here, a lot of this is just so you understand that all this is happening underneath, and we're a world of bacteria, but as you're working with farmers, the one thing you need to keep in mind, this is the question I put down, is you need to learn and help them understand what to do to maintain and support these guys we're talking about. the bacteria and the fungi. What do we need to do? What will maintain and support these? Now, one thing I want you to know too is that some of the microbes we saw in that picture were protozoa and nematodes. And they're very important because guess what? The nitrogen that's in the bacteria and the fungi is kind of locked up until these guys come along and chomp on them and eat them. And then as they die and dissolve right in that biosphere, guess what? Now it's released and it's able to be taken up by the plant in the forms of ammonia and nitrates. So, but remember, your job is to figure out how to keep these bacteria and fungi going.
Yes, and the key thing, we are always coming back. When you combine all these principles, you have no problems on these sides. You see, the whole bacterial and fungal world actually is a key aspect when it comes to plant health. So they help to mitigate stress factors, whether they are biotic or abiotic. Abiotic means temperature, humidity, drought situations. The bacterial world plays a key role in mitigating these stress situations of plants.
Thank you so much, Papa and Papa Fred. You see, this is one of the most interesting sessions because now you get to understand the relationship between the science and what you have seen out in the field.
This is why it's working, or isn't working.
Because of that, a lot has so far been said. 5-minute break, let's sink in, then we continue. Okay? Thank you.
Thank you.
5 minutes, please. Try to be time